Hey guys, so today we're going to be completing the alternative chair conformations for the molecules shown. So to go ahead and start, they did give us this and they did give us this. So what they're asking essentially is, we notice our hydroxyl group right here. They're asking us to fill in where these molecules would go and what position they'd be in. So to get this started, the first tip I want to emphasize is to look at the placement of each molecule. So for this first part, I'm going to name this A and name this B. For this first part in A, we notice that this methyl group on 2 is pointing downwards. This means that this must be below the plane of our ring. So if we move to 2, if we're starting off at 1 here, and they did give us the OH here, and they did give us the OH here. If we're starting off at 1 here, our 2 is going to be right here. So if 2 is right here, we have to consider what position right here, either axial or equatorial, will give you a CH3 that is below the plane. So for here, in order to get a CH3 below the plane, we must know the position. So to begin with, our axial points straight down here, and our equatorial is actually pointing up. And if we want a CH3 that's below the plane, we need the one that's pointing down. So here, this carbon, the CH3 group right here, must be axial in order to be below the plane. And now, the CH3 group on carbon 4 is actually above the plane, which is demonstrated by this wedge right here. Now, we have to move to spot 4. So this is 3 and this is 4. It may help you to possibly draw every, sort of, let's say, positioning that could be, so you can kind of follow. So, at 3, I would have an axial up and an equatorial here. But the next part, and a way to memorize this is by knowing that your 1,3 dimethyl interactions that cause the steric strain. Anyways, so for number 4, right here, I'm going to zoom into it. For number 4, my CH3 group needs to be pointing upwards. But here, my axial and my equatorial group have an equatorial going upwards and an axial going downwards. This means that although hydroxide is in axial here, and although the methyl is in axial but it's pointing downwards, my group for 4 needs to actually be equatorial. And again, this is because the methyl on 2 is pointing downwards below the plane, but the methyl on 4 is pointing upwards. So now let's go ahead and complete conformation, the second one, which is kind of the ring flip. So our hydroxide moves down, and once again, our hydroxide needs to be, as we can tell, it is above the plane. That is demonstrated by this wedge right here, and we notice it's an equatorial because an axial would come straight down. So for 2, our methyl is below the plane, and that means it needs to be pointing downwards. We know our hydrogen is going to point upwards right here in order to complete that octet, which means that our 2, right here, our methyl is actually in the equatorial down position, CH3. Now moving on to 4. We actually already know that this is going to be our equatorial and axial position here, but we know that for here we need our CH3 group to be in the up position because it needs to be above the plane. That means that our equatorial is going to point down and our axial is pointing up. And with that knowledge, that means that our CH3 must be axial in this position. And that would be us completing the alternative chair conformations.